Okay, so this is our 20% glucose solution, and we're gonna actually be going to dilute that so we can obtain our 10% and our 5% dilutions, right? Glucose solutions. And then here in this container, we actually have our dialysis bags. And these, we are actually gonna rub like so in order to be able to open them up. So the reason why we put them in water to soak is so that we can be able to open them up. See? Because this is how it actually looks like when it comes in a packet. Very thin, very hard to open up if you don't soak it up in water first. See? These are the dialysis bags we're using for our experiment. So what we hypothesize is that our glucose solution bags will gain weight as water will move into the bags in order to make concentration inside and outside the bags equal, right? And then in our isotonic solutions, there should be no net movement of molecules. And in the dialysis bag with water placed in the beaker with the 20% glucose solution, that bag should lose weight because the water will move out of it in order to make the surrounding concentration come down, right? And then the other bag that was placed in just water, that's the isotonic one, so no net movement of molecules. Okay, so here I'm back. I actually put some gloves on. You don't really need to since it's just a glucose solution, but you know, trying to give you all the works. So this is a dialysis bag. This is kind of how it should look. So once you put your solution in, you can use a transfer pipette for that. You should leave a little bit of space, like a little air bubble at the top, as you can see. So that space, we leave it because our bag is actually working as a cell, right? So in a cell, our water can come in and go out of the cell. That's called osmosis, right? So it usually travels, it actually travels from regions of high concentration to regions of low concentration of water. But when it comes to molecules, it's actually traveling from hypotonic to hypertonic solutions. So that means that it's traveling from solutions that have low concentration of solute to solutions that have high concentrations of solute. And it does this in order to bring down the concentration levels, right? So that they can reach equilibrium, so that they can be in an isotonic environment, like an isotonic solution, just like so, right? And so our little bag, this little bag should actually be gaining weight at the end of our experiment, since this is a 20% glucose solution inside it, and we're gonna be putting it in a solution that is gonna be actually just water. So that means that the concentration of glucose inside our bag is going to be a lot greater, right? So what that means is that our water is going to move inside this little dialysis bag, right? Just like it would move inside a cell in order to bring our concentration down. So. Okay, so as you can see, we have our water beaker container right here now. And here is our little bag of the 20% glucose solution. So basically what's going to happen with all of these solutions and bags that we're going to make, right, is we're going to put them into the container, right, wait about 20-30 minutes, right, and we're going to weigh them at the end and see what the difference is between its initial weight and the final weight. So these glucose solution bags that are put inside the beaker with just water, we expect them all to gain weight, right? And the other two solutions, which are just going to be bags with water, one of them is going to be put in this beaker, the same kind of beaker with just water. That's going to be an isotonic environment, so that should stay the same weight. And the last one, the last little bag with just water, is going to be put into a beaker that is actually 20% glucose solution. So that one should actually lose weight as the water is going to move out of the bag into the solution to bring the concentration down. And that, my friends, it's basically all. So you just have to wait about 20 to 30 minutes, take your weights and take your differences, and that will prove, my friends, that water moves from hypotonic to hypertonic solutions. And that's it. That's your experiment for osmosis, cellular transport. Hi, so I just want to show you my face, and my lovely assistant Michelle is right now taking the video.